Hello, and welcome. Time for our third talk of the session. So here we have Alex Petralia, and he was most recently working as a data engineer at a financial trading company. And if you thought averages and means were easy, well, Alex is here to tell you about the things that he's learned using pandas and SQL, taught about taking an average. So let's give a big round of applause now for Alex.
Hi, everybody. Is this on? It's not on? It's working now. My name is Alex Petralia, and today I'm going to talk about what pandas and SQL taught me about taking an average. I want to set the scene a little bit first. It was 2016. I had just been hired to Tower Research Capital in New York City, and I was going to be a data engineer and a data analyst. And my day-to-day would really be working with code. I had come more from a background where I worked in Microsoft Excel, and now I'd be working primarily with pandas and SQL. So I'd be working with code like this to pull in data, manipulate data, transform it, validate it. Every type of data really was in my purview, whether it was tables, simple tables, databases, less structured data, XML, and so on. And my job was to take information and data and turn it into meaning, to identify patterns, ultimately to drive conclusions from the data. And what's pretty typical when you first start a job is you get very simple kind of exercises to familiarize yourself with the data, to familiarize yourself with the domain, the institutional knowledge. And my manager was pretty aware of that, so he said, OK, we're going to start by giving you something pretty basic. It's a kind of a report we run pretty often, and I'd like you to calculate the statistic, which is our average daily trading volume. So he asked, can you calculate our average daily trading volume for each exchange we trade on? And I said, OK, no problem. This is pretty straightforward. Right? For each exchange, calculate an average. Not so hard. So I eagerly jumped to the code. For extra credit, I even do it in both pandas and SQL. And you can see it's kind of a translation, really, of the English question, which is for each exchange, group by exchange, calculate the average, calculate a mean. So I produce a visualization. It looks pretty good to me. All done. I send it off to my manager. And he looks at it, and he says, 6? Like our average daily trading volume is 6 trades. On NYSE Arca, we do 6 trades. And I go, no problem. There's probably a typo. This happens all the time. I go back to the code, and I say, OK, for each exchange, calculate the mean. And this code is absolutely right to me. I was absolutely sure this code is right, which is a big problem because that shows I have no idea what I'm doing. It was clearly a conceptual issue. It wasn't a problem with the code. And my manager realizes this. He looks at my code. And he realizes as well that this is a conceptual issue. We have to go back to first principles. So where do we start with first principles? He asks, what do you think an average is? And I can tell you, if you are hired as an analyst, you work a lot with averages and just calculating statistics, this question really gets at the core of your identity. So I was a little bit nervous, and I probably said at the time a really bad answer, and I equivocated. I wasn't really sure. But fortunately, my manager was helpful enough to walk me through exactly which misstep I made. And that's what I kind of want to detail today, which is that I learned that an average is a little bit more complicated than we initially think. And we've only really visited it once back in grade school. and we never really come back to it. So I want to kind of investigate what is an average. We'll do this using one-dimensional data. We'll do two-dimensional data, three-dimensional data. We're going to get to what I call the pitfall of multidimensional averages. And then there's a magic formula so that we don't run into this pitfall. OK, so this is a good question. What is an average? We can look at this formula and say, OK, well, I sum up the numbers on top. I divide by the count, the number of observations. That maps on pretty cleanly to SQL. Take the sum, divide it by the count, no problem. We can see this with an example. So if I ask, what is the average amount of apples sold? We can all just calculate the average here. So we take the sum of all the numbers, that's our numerator. We divide by the count, that's 5 observations. So we get 6.6. This maps on to SQL pretty cleanly, sum over the count. Again, pretty clean here. And we could also use the average as a convenience function, does the same thing. So now we're going to move to two-dimensional data. And I'm going to tweak the question just a little bit. So now I'm going to ask, what is the average daily amount of apples sold? So is our denominator still 5 here? It's not. It's 3. Because we have 3 unique days. So on an average day, we sell 11 apples, not 6.6 as before, because we've changed the question. This SQL is a little bit more nuanced. We get the sum in the numerator, but now our denominator has changed. It's count distinct date. So we're kind of aggregating as before, but we're making sure that our denominator just has the unique values we care about. This would not work. This is what we had done before. This answered the previous question, but it doesn't answer this question. So what do we need to do? The first thing we need to do is we need to aggregate this data to make sure that we're dealing with 3 rows. So that's the first thing we do. We have to aggregate the data, make sure we have 3 rows. Now, this is the data set here that we want to take an average of. So we could structure this and say, well, take this query, but just wrap it in an outer query. So take an average of this thing. We're going to make this thing our inner query and put an outer query around it. And now we get 11. So we have 11 apples sold on average. You could also do this in pandas. I know I've done a lot of SQL here. This is a Python conference. So all of these will still apply directly to pandas. Same thing, what we're doing is we're aggregating the data and then taking the average. So what's one thing we can notice from this? The question matters. As we change the question, our answer is going to change. The code that gets us to that answer is also going to change. That kind of makes sense. More specifically, if I'm asking for a daily average, I'm not just taking an average across like the number of rows. I'm taking an average across a specific column, and that's the date here. So at a high level, what's going on? If I don't aggregate the data, I'm simply taking an average across the primary key. Right? That's kind of like the default. That's how many rows we're going to get by default. But what I want to say is for this analysis, I want to proceed at a different level. If our analytical question changes, I want to have control of that. And I have to specify that we're going to use the date column to do it. That's what the inner query did. The inner query says, that's what you defined as the primary key. That's fine. But for our question, we actually have to make sure we're aggregating at the level of date. Because it kind of functions like a primary key, I'm going to call that a collapsing key. So what we're doing is we're preparing a data set for our analysis, And this data set kind of functions, it kind of has this primary key, but we're collapsing the data before we do anything with it. And that's what I'm calling the collapsing key. And this jargon will make sense in a bit when I tie it all together. We can stop for a second. What's the point of all this? Well, it kind of seems like, why do I have to use this subquery? Why do I have to use an inner query and outer query? What's the point? Well, I want to remind everybody that we always work with multidimensional data sets. So we want to be aware of what we are taking an average of. And if we're not pausing to think about it, we might be taking an average of something completely different. So I think it's relevant, and hopefully it applies. We're going to go a little step further here. So we just did one-dimensional data, we did two-dimensional data, now we're going to go to three-dimensional data. And instead of asking what's our average daily amount of apples sold, we're going to do that same thing, but say, for each seller. So for each seller, what's their average? We might expect to have an average for Mary, an average for Bob, an average for Jane. And we can probably just eyeball this, right? Like a good way to sanity check stuff is just to do a simple example, make sure it gets the right results. So for Mary, we can calculate an average. 5 divided by 1, that's one row. She sells 5 apples on an average day. Bob sells 12 apples over 2 days. Jane sells 16 apples over 1 day. So it's 16. In this case, we will have to collapse our data. And if you think this data set is contrived, you can imagine that we simply have multiple columns there, like a few extra columns where we have city, we have sales territory, whatever. These can be individually distinct rows at the table level, but for our analysis, not really, they're not unique observations. So what's the first thing we have to do? Well, we have to aggregate this data. The query on the right produces the output on the left. And again, what we're doing here is we're replacing the primary key with our own key. That's at our level of analysis. That depends on this question. And that's what I call the collapsing key. But we're not done yet. We actually have one more thing to answer in this question, which is for each seller, what's the average, right? We're not there, so this is intermediate. We have our inner query. We can wrap that with an outer query. And now we have our answer. For each seller, Mary sells 5 apples on an average day, Bob sells 6, Jane 16 on an average day. This part here, this last part, the group by seller, I'm going to call that the grouping key. And I know everyone's like, okay, way too much jargon, and it's going to make sense in a bit, so wait for it. What are some definitions? What is this stuff? The collapsing key prepares the data set for this analysis. Again, what we're doing is we're overriding the primary key, whatever that happened to be, might not be relevant for this analysis. So we're collapsing the data first. Then, if the question asks for grouping, we'll do some grouping. So if it asks for each seller, then we group by seller. Okay, so we've seen the collapsing key, we've seen the the grouping key, but there's something here that's conspicuously missing. This daily part, right? Like we're taking an average across days, it's a daily average. And yet I don't see it in the query. That's a bit confusing. So I can look at this data set and I say, okay, there's definitely a daily part and there's definitely a for each seller part. That's like pretty important. So I'm going to introduce one more definition here, and that's the observation key, which is a unit of observation for this analysis. So if it's a daily average, then it's an average across dates. If it's a regional average, then we expect the number in our denominator to be whatever we're taking an average of. So that's our observation key. This is the relationship that ties them all together. the observation key, the thing we're taking an average of, it's the difference between the collapsing key and the grouping key. That most important thing, the fact that this is a daily average, it's the difference. It's completely implicit. It's implied. We can look and see it's date seller in our collapsing key, minus seller in our grouping key, and we get to date, which is our observation key. That's what I call the pitfall of multidimensional averages, which is that the thing we're taking an average of, it's implicit, it's implied. It's not part of the query. That's pretty confusing, I think. So this is the relationship we can use. This is the magic formula we can use to solve this problem. Again, we can also do this in pandas. We have a first group by, which aggregates the data, collapses data, and if our question asks for grouping, that's the second group by. And again, the date part, it's implied. So how do I actually parse a question like this? Like, if someone assigns me this question, what am I thinking? Well, I'm thinking, okay, I can see the observation key, that's daily. I can see the grouping key, that's for each seller. The collapsing key, well, I can move terms a bit and say, okay, well, that's the observation key plus the grouping key. Therefore, the last thing I kind of impute in this question is the collapsing key. But ironically, it's the very first thing I write. It's the first thing I write here. It prepares the data set. I need to do my analysis, aggregates the data, the level that we need. And then if the question asks for grouping, we do grouping. And again, this part I never even write. The observation key is simply the difference between the collapsing key and the grouping key. Date seller minus seller equals date, right? And the state part I don't write. So one takeaway we can see here, this is probably true for all software, which is that we always have to figure out what we're doing, what's the question we're solving, why are we doing it, before we actually write any code. That was probably one thing that jumped out when I first jumped the code initially, which is that I didn't really think about the problem, right? That could be problematic. Okay. So if everyone sees a formula, they're probably thinking, what happens if I don't use some of these, if I have the term as 0? So I was curious myself, what if we don't use a collapsing key? So what if we don't have that inner query? What if we don't have a grouping key? And what if we don't have either a collapsing key or a grouping key? Let's investigate. If we have a blank collapsing key, well, I can look at this formula here. And in fact, we've actually run into a data set like this. If I simply take the average of this data set, and there's no collapsing going on, there's no inner query here, then what am I taking an average of? Well, it's how many rows are in the primary key. So it's simply the primary key. And that would not answer this question here. What is the average daily amount of apples sold? This would answer something else. It would answer just an average of the data set. So again, what I actually have to do is I have to collapse the data. And that's what that inner query does. We do that with the collapsing key. One thing we can see then is if you don't define a collapsing key, then it defaults to the primary key. That's just how many rows we have in our data set. And that's how many rows we'll get in our denominator unless we collapse the data before that. So we do that using an inner query. So this is the formula we can use. We have this inner query, we have this outer query. The observation key is the difference. We can see that if we don't have a collapsing key, we'll simply get the primary key. The rest of this holds, still works. Again, this query would not work. Why does it not work? Or what's problematic about this? It's that we don't know what some database admin, what some data engineer put in as the level of granularity they want to store in the database. Like, that's some level of granularity, but it might not be relevant to our analysis. And if we don't collapse the data, we're simply assuming that that's the right level of granularity, which is probably a dangerous assumption to make. So we have this formula. we're going to see what happens if we have a blank grouping key. Well, this grouping key part will become nothing. We have our collapsing key equals our observation key, which, using this last example here, we've seen already, which is that if the question doesn't ask for grouping, if it doesn't say for each cell, or if it just doesn't ask for grouping, then we don't need a grouping key out here. This still holds because we have the date part minus nothing, and therefore we're taking an average across days. Right, that's how we know. And we can go one step further. What happens if we don't have either a collapsing key or a grouping key? Like, then what? So we can look at this and say, well, the collapsing key is going to be the primary key. The grouping key is going to go to nothing. And so we have our primary key equals our observation key, which also makes sense. Because if we don't collapse the data, we're simply assuming that the relevant level of analysis is the primary key. So if I ask a question like this, what is our average amount of apples sold? Like, everyone should probably think, like, average what? Like, what? What are we taking the average of? Well, in this case, it's the primary key. And that would answer this question, this like super vague question. That's fine. But if I wanted to answer this question, which is what is our average daily amount of apples sold, that would not work. We'd be taking an average of the wrong thing. We'd be answering a different question. So this would not work. In this case, the observation key, simply the primary key. Again, it's not answering this question. It would work if we answered a more vague question. This is really what we should be doing, to emphasize. We should collapse the data first, and therefore the date minus nothing means our observation key is date. Again, the question to always ask is, what are we taking an average of? Well, we're taking an average across days. It's a daily average. So this is the formula we can bring with us. I want to take another step back and say, what's the big deal of all this? Like, there's a lot of subquery stuff. Do I really need to use this stuff? And I want to just briefly show what happens if we don't do this. If we just totally ignore, that's fine, okay. Let's do an example of the right query. And we get a certain answer. 11. 11 apples sold on an average day. If we use the wrong query, then we will get the wrong answer. We'll get a completely different answer, right? And if anyone's worked with data analysis at all, you know it's easy to produce wrong results that look right. So can anyone spot the difference between these two results? Probably not, but one is correct and one is not correct. So these errors are not easily identifiable, but they can actually have a large magnitude here. If we don't collapse our data, to go back here, if we don't collapse our data to these 3 rows, we're going to have too many rows in our denominator, which means too low an average. So we'll understate our results. What's the big picture in all this? Well, I can say from experience that as a data engineer and data analyst, and probably everyone here has a similar experience, it's extremely easy to get stuck in the minutia of the code, to get stuck in the details, to make sure that the thing just runs. But one thing I want to emphasize is that sometimes it takes putting on a different hat to figure out, does this result make sense? What am I actually doing? What's the problem I'm solving? To take a step back and review the results that you've produced. More specifically, if you are simply using mean or average and not really thinking about it, you're not really asking, what am I taking an average of? Well, the code's not going to know either. And it could just be calculating an average for something, but it won't be the right average. If we're aware that we're dealing with multidimensional data sets, then we will run into this issue where we could be producing and calculating the wrong average. If you take this formula with you, which is that our collapsing key minus the grouping key equals the observation key, again, the observation key is what we are taking an average of. If you take this with you, you'll be able to avoid a lot of the mistakes we see that show up in data dashboards, management reports, presentation decks, everything. You'll be able to avoid those errors and produce more correct analyses. Thank you.